So, what if the entire way we built software was about to change, like forever? And no, I'm not talking about some hot new framework or a programming language. We're talking about a massive shift from being a coder, writing line by line, to becoming a true system architect.
Just think about that for a second. What if the most grueling part of development, that endless cycle of typing, testing, and debugging, was just not your main job anymore? It sounds like pure science fiction, I know, but it's the exact future we're going to dive into right now.
All right, to really get where we're going, we've got to be honest about where we are. For decades, building software meant you were stuck in the weeds. It's a manual and, let's be real, often frustrating process. Let's just call it yesterday's code, and it's got some serious limitations. This slide just nails the difference. On one side, you've got the developer as a bricklayer, carefully, painstakingly placing each line of code, one by one. It's slow, and a single mistake can mess up the entire thing. But on the other side, the developer is the architect. You design the blueprint, you perfect the grand vision, and then you let automated tools handle the actual construction. That, right there, is the heart of spec-driven development. So you see, this is way more than just a new tool or technique. It's a completely different way of thinking. It's all about elevating your role from a hands-on builder to a high-level designer, focusing on the what and the why way before you ever get to the how. At its core, spec-driven development is really a partnership. You bring the human intelligence, the design, the rules, what we call the specifications. Your AI partner then takes that blueprint and builds the actual working code. It's a pretty simple contract when you think about it. You design, it builds. And this quote? This is the mindset shift right here. Your focus just elevates. You get to escape the nitty-gritty of syntax and semicolons and start thinking about the big picture, the system's architecture, and the core rules that make the whole thing work. So, what's the whole point of all this? Well, it's about learning this new way of creating things. It's about shifting your identity from coder to designer, and ultimately, it's about building this incredibly clean, scalable foundation for your projects, all while having an AI as your dedicated engineering partner. Now, this isn't just some high-level theory. It's a practical, repeatable process. So how does it actually get done? Let's take a look at the blueprint. Okay, here's the 5-step process. You start with what's called the constitution. These are the big foundational rules for your whole project. Then you write detailed specs for every single feature. From there, you create a high-level plan for the structure. You break that plan into small, bite-sized tasks for the AI. And then, this is the magic part, the AI generates the code. Notice what's missing? Zero manual coding in that final step. So, the big question, does this actually work? Well, the proof is in the product. This entire process was used to build a complete, functional application totally from the ground up. And what was the result? A classic to-do application. Yeah, a simple but totally complete Python app that runs in the console, and it was generated 100% from the specifications we just talked about. Not one single line of implementation was typed by a human. And hey, this isn't just some empty shell. It has all the core features you'd expect, right? Adding, viewing, updating, deleting tasks. You can mark them as complete. It's a real, useful tool. And a person wrote 0 lines of the implementation code to make it happen. Wild. And if you peek under the hood, the architecture itself is clean and professional. It's Python 3, runs right in the command line. For now, data is stored in memory, but the key thing here is the design spec. It was built to be modular and extensible from day one. This wasn't just built to work, it was built to grow. And that brings us to maybe the most important point of all. This whole experiment was never just about building a simple to-do app. It's really about what this kind of foundation makes possible for the future. This right here is the real payoff. When you start with a perfectly designed AI-generated core, you're creating this solid architectural foundation. Everything that you want to build next, a web interface, cloud deployment, brand new features, it can all be built on this clean base without all that technical debt that just cripples so many projects. So what did we learn here? Well, this whole thing proves that your specs directly control the final code. It shows you can fully design a complex system before a single line of implementation is written. It validates that an AI can be a truly reliable engineering partner. And maybe most importantly, it produces software that is, by its very nature, ready to evolve and scale. You know, if you remember one thing from this explainer, let it be this. This is no longer just an idea or a hypothesis. Good specifications can and do generate working software. It's a proven concept.
And all of this leaves us with one last really fascinating question. As we move forward, is the most valuable skill for a developer no longer the ability to write code, but the ability to think with absolute clarity and then communicate that clarity in a specification? Something to think about. Thanks for diving in with me on this one.